Today we're going to talk about the results section because I know it's becoming a problem for some of you. It's important to pare down the variables you will need to be, so you'll be able to need in your results section. It's important to pare down the variables that you will need to use to be able to answer the research questions that you posed at the beginning of the course. So if I give you an example, the volleyball burnout survey that I use for my capstone, each question goes to the variables in the actual research questions to be able to answer them at the end. Some of you have as many as 11 to 15 variables, and in a couple minutes you'll understand why I keep sending you back, meaning you need to break it down a little less. This is the section in the syllabus, results, expected results for the study, that is linked to previous research findings, 1 to 3 paragraphs. That's 3 paragraphs. If you were going to do 11 variables, it's going to take you 11 paragraphs to get done, if not more, and a whole bunch of tables and everything else to complete what you need to do. Included sections are demographics, information about your subjects. Again, descriptive statistics, which falls into the same area. Provide the number of subjects, means, standard deviation, standard error, and other descriptive information. Okay, statistical answer the research questions using descriptive statistics and statistical analysis data. I'm going to show you what you need to do. First section, demographics. Tell me about your participants. Keep your numbers low, 30 to 50. Some of you have 5,000. For everything you do, you have to split up the 5,000 numbers. You're faking a study, 30 to 50 participants. 30 is a wonderful number, 15. It's easy to work with because you have to show those numbers. Okay, in the demographic section, number of participants, age, give range from they went from age 11.22 to 22.88. Okay, the mean is written with an M, cap M, and it's italicized. All the Greek letters, all the little letters are going to be in with a big M. Race, white, black, Asian, Pacific Islander, and you're going to get percentages that you're going to make up. They'll have to add up to 100. Socioeconomic level, upper, middle, lower class, giving percentages. Here's an example. There were 30 participants in the study, including 20 men and 10 women. The participants' age ranged from 19 to 21 with a mean age. You can read the rest of this, so you'll have this. So read this. This is how you formulate it. You notice it says large city and a percentage, and it goes from big to small, upper, middle, lower. You can follow this as an example. A paired sample t-test is to examine 2 sets of numbers to evaluate whether the first scores increase or decrease from the second set of scores. The next example shows the mile times for old folks, like your professor, in a 6-week running training session. So you can see the times here. These times was the first time, this time is the second time. Going all the way down, this is participant 1, this is participant 2, and see if there are times. You can look at this one, but if you had a large set of numbers, you wouldn't be able to tell. So we'll move on to the results. Once those numbers are in and you calculate them, this is SPSS, and this shows you a lot of data. Some of it you need to know, some of you don't, but you already have an idea. Going back to the pen, this is the mean for the entire group for time 1. This is the mean for time 2. Okay, in this case, this is how many participants we had, were 10, and this is your standard deviation. So this first standard deviation would be written 3.24, and this one would be 2.53. So you can see how the time decreased right here. So you already have your conclusion. This is the mean down here is this minus this, so you have 1.61. Okay, basically it was highly correlated, and it was very significant because this was greater than 0.05. Okay, all of this down here I'm not even going to worry about. Worry about your means, worry about your people, and I'm not sure if you need standard deviation, but if you did, this is the numbers you would pick. Remember, you're making this up. Here is an example, paired sample t-test. This is a different one. I just grabbed it so you can have it. So you're going to need your mean and your standard deviation. You see the mean is a cap M, standard deviation is a cap SD, and they're both italicized every time, spaces between the equals. And basically it's set up this way. This is an introductory sentence. So this would be like a paired sample t-test was conducted on old folks, and mile times before and after in a 6-week training program. There was a slight difference, which would be right at 1.61 in the scores in the mile times before and after the training program. Then you'd have your mean and your standard deviation for before and then after. The results showed the athletes had an improved mile time in the 6-week training program. Therefore, old folks who participate in a 6-week training program can improve their mile times. That's as simple as it gets. Correlation. It's to establish relationship between two variables. Pearson correlation is denoted by a little r, and it is in italics. In this case, if you're doing a survey, you're doing a fake survey, so you know the questions that you want to ask. Place 2 questions together, and you need about 3 total sets of questions to be able to do it. So I'm going to give you an example. This is my capstone. This is one of the correlations. They're frustrated with the volleyball coach right here. They're frustrated with volleyball. Sorry, let me grab the pen. They're frustrated with volleyball, and they're annoyed by their coach and or teammates. This is what a correlation box looks like. This number here is 663. Okay? On a line, which I can't draw with these pens very well, with the thing. Correlations are set up from -1 to +1. These are perfect correlations. This is a perfect correlation because annoyed and annoyed would be the same. You'd have the same answers. 0 is in the center. Okay. This one is 6 positive. We pretend there's a plus there. Positive 0.663. And let's say for general purposes, it changed to a -663. In this case, these two numbers are the same because they're the same distance, not like a number line in math, from 0. So this would be a positive correlation, and this would be a negative correlation. Okay? Stay with the positive in your paper. Okay? So point toward the positive correlation between frustrated with volleyball and annoyed by volleyball coach and team. Okay? It does not matter where it is on the continuum on either side. It's just the number of, if this was 0.090, this would be slight, in the middle would be middle, and then this would be high. Okay, so this is highly correlated. The significance level tells you that it was significant. It's not a big deal, but you just need to know that it is significant. Okay, moving on. So basically, here is the actual write-up for that. Okay, Pearson product moment correlation coefficient was computed to assess the relationship between being frustrated with volleyball and annoyed by volleyball coaches and teammates. There was a high positive correlation between the two variables. R, italicized, 0.663, that was the first number we circled. N equals 30, or whatever your number is, and P was at 000. Overall, there was a strong positive correlation between frustrated with volleyball coaches and annoyed with volleyball coaches. What does that mean? Real simple. Where is it? So, the correlation kinda, because it's not you're not sure, that there is a possibility the athlete is a frustrated player, because of the annoyance of the coach or other teammates. So what you want to do is take two of them together, pick a number on the positive correlation side, write it up like it was on the other page, and then make a determination that will answer your central research question. Thank you.